Analyzing the production of carbonated drinks requires mapping the physical flow of materials. The scope spans from the intake of raw water to the delivery of finished goods. The pipeline is organized into 5 distinct stages, each transforming the liquid. The first stage is dedicated to water purification, ensuring a clean baseline before any ingredients are added. The final stage is focused purely on the logistical requirements of packaging and transportation. Before reaching the carbonation phase, the raw water must undergo a series of extensive treatments to remove impurities and adjust its chemical properties. Only after the water is carbonated does the system introduce the sequential additions of coloring, syrup, and flavor. Once the liquid is finished, the pipeline splits it into 2 specific container formats: glass bottles and aluminum cans. Even though the containers differ, both paths converge into an identical packaging and shipping process. To accurately describe this system, we must treat this continuous physical flow as a series of discrete logical blocks. The process begins at the starting point of the pipeline, where raw water is first introduced to the system. First, the water is passed through a mechanical filter to remove large particles and debris. From the filter, the water travels directly into a treatment chamber. Inside, it is softened and mixed with chemicals for further processing. Once purified, the water is pumped out of the first zone and into the thermal processing stage. Electric heaters rapidly increase the temperature of the water as it passes through the system. This heated liquid is then immediately routed through a cooling pipe. Downward arrows in the diagram indicate the rapid drop in temperature during this phase. This thermal shift is a requirement for the next phase, moving the liquid into specialized formulation. In technical writing, this cooling phase marks a clear change to the carbonation stage. This temperature drop is functional. Cold liquids absorb and retain dissolved gases far more effectively, preparing the water to receive CO2. The cooled water now enters the carbonation chamber, where the core transformation of the product occurs. This is the point where the system introduces carbon dioxide. The clear liquid violently effervesces as highly pressurized carbon dioxide gas is forced directly into the chamber, rapidly dissolving into the water. Injection nozzles drive the CO2 directly into the purified water at a controlled rate. At this stage, the CO2 molecules bond with the water, creating the carbonic acid that provides the drink's carbonation and tartness. The water that entered the chamber as a flat, purified liquid leaves it as carbonated water. This specific mechanical step is what defines the final product's identity. Describing this transformation provides a natural break between the preparation of the raw materials and the final assembly of the ingredients. With the carbonation complete, the liquid has transitioned from a raw material into a functional base for the beverage. The carbonated water is subsequently transferred to a large mixing tank for the final stage of formulation. 3 specific additives are introduced here to complete the drink's profile. Coloring, syrup, and flavor are poured into the tank and integrated with the carbonated base. A massive mechanical agitator inside the main tank continuously ensures these various ingredients are thoroughly blended into a completely uniform mixture. Before packaging, the finished liquid passes through a secondary filter to remove any remaining inconsistencies. At the end of the line, the production path splits into 2 separate streams. Some of the liquid is poured into glass bottles. The remainder is routed to a different line and filled into aluminum cans. This volumetric split allows the factory to produce 2 different product types from a single batch of liquid. Despite the difference in containers, the bottles and cans converge into identical cardboard boxes for the final packaging stage. These boxes are loaded onto delivery trucks and transported to supermarkets for retail sale. This configuration allows the factory to output 2 retail formats while merging them back into a single shipping stream. Viewing the entire manufacturing sequence as a single system reveals the logic behind the factory's layout. The process moves sequentially from raw input to a dual-format retail product through a series of specific mechanical and chemical changes. Understanding how to map these physical transitions into a clear, structured sequence is essential for analyzing complex processes. This structural breakdown was brought to you by the experts at the IELTS Focus. You can reach them via Zalo for targeted preparation strategies and guidance to help you achieve your goals. Systematic analytical skills are universal. They allow you to deconstruct an industrial pipeline or master the requirements of a standardized exam with the same level of precision.